Hello, everyone. Welcome to today's session. Welcome, everyone, to today's session. Is your one and only Ukeme, moderating this event today. And this is the second session in our series on the advanced curriculum. So today we'll be covering app containerization and orchestration using ECS. So the description here is to deploy a DevOps Bank app to Amazon ECS, which is the Elastic Container Service. And we have a guest in the house today, God's Time. Let me bring him up on stage. Hello, God's Time. How are you?
Hello, good evening, everybody. Yeah, it's nice to be
Yeah.
back.
All right, great. So, God's Time covered the beginner's session on Wednesday, and today we're going to do something a bit more advanced. We
I think
then after that we have um. Oh, okay. So I'm going to leave you in the hands of God's Time. God's Time. Is your shot. Shoot your shot.
hi, good evening, everybody. My name is God's Time Wade. Somebody said the other time I did not introduce myself. Sorry. I am a DevOps engineer like you. I am an AWS community builder and a code cloud ambassador. So today we're going to be discussing container orchestration with Amazon ECS. So I'm going to be putting up my slide right now. This is a hands-on section, but I like to start with some few slides to like give us a perspective of what we are talking about. Thank you. So we'll be talking about Elastic Container Service, AWS Elastic Container Service. So what is Elastic Container Service? All right, let's dive in. Okay, I think this slide is taking time to load. So containerization, we all know what containerization is from Simin's lectures, from his hands-on session. We have been able to like grasp the full meaning of containerization. So it is in summary packaging of application code binaries or the dependencies your application needs to run and bundling up into a single bundle called a Docker container or a Docker image. So Docker tried did not try. Docker brought up an orchestration platform with Docker Swarm, where you have to like embed Docker in all your from Dockerizing and then orchestrating it. Then Kubernetes made it better. And then now we have ECS, Amazon Container Service. So ECS and EKS, Elastic Container Service, they do the same thing, but in different ways. In the sense that ECS is AWS product, like it's fine-grained to AWS, embedded in AWS services, so it has so many integrations with all the AWS services. Why EKS? Kubernetes is an open source container orchestration platform. So it's not cloud. It's not. You don't have vendor locked in with when you're using Kubernetes. It's very, very, you can use it, carry it and use it on different places. But ECS, if you are running Kubernetes on cloud providers, you find out that the cost of running it, the cost of maintaining that control plane is quite big, it's quite huge when you compare it to using ECS. So AWS brought ECS to handle container orchestration for Docker containers and other container services. And this ECS has like streamlined deploying your containerized applications to the cloud, to different environment, to production, staging, and other workloads. So today we'll be talking about ECS. And then because I am a serverless community builder, we'll be focusing on ECS Fargate. So Fargate is a serverless service for AWS, and then it integrates with ECS. So you run your container without bothering about the underlying infrastructure. All right, so next slide. I'll try and be fast with this slide because we have some demos to do. So prerequisite. Before you, if you are practicing, if you are doing this with us while we work, you need these tools. You need an AWS account. You need to have an IAM role with required permissions. You need AWS CLI, where you can log in and then write some CLI command to access AWS services. And then you need a Dockerized application or an application you can Dockerize here. So that's basically the prerequisite for this hands-on. So what we are going to do, we are looking at, this is ECS ecosystem. So ECS, first of all, a container has to be in a registry. And then so is that container that is working, that is in a registry, either a Docker registry, your local registry, or for us, we'll be using Amazon Container Registry today. So ECS is a container service. So from here, ECS, your Elastic, ECR, I've been saying ECS. So we'll be using ECR, Elastic Container Registry, for hosting and storing our containers. Then when you write your task definition, you specify the container you want ECS to orchestrate. And then there are different launch type. You can either use Fargate with EC2 or just Fargate. And then voila, your container will be orchestrated via ECS. So ECS actually makes it very, very easy to orchestrate your container, to run your containers. It streamlines takes the heavy lifting off you, and then it just packages your container, builds it, and then runs it on dedicated for Fargate using AWS provided instances, but they are serverless in the background. You don't have to be worrying about capacity. You just have to like specify, okay, this is what your infrastructure should look like. All right. So next, I'll be talking about ECRO first. Yes. So Amazon ECRO is a fully managed container image registry service provided by AWS. It serves as a secure and reliable storage solution. It integrates seamlessly with AWS services. It's secure. You can only access it with right IAM roles and permissions. Then you have image lifecycle management. You can disable, enable tag immutability, and then say this image should go at a particular time. Yeah, you can scan your images. You can have secure images. You can encrypt your images using KMS. Yes. So I'm just giving us a high level overview of the services in concern. So a cluster, so we cannot talk about ECS without talking about ECS cluster. So ECS cluster acts as the orchestration platform. It enables you to efficiently manage your multiple containers across different clusters or instances or tasks. So it abstracts the complexity of container deployment, like we've mentioned um, in the other slides. So task definition. Yeah, a task definition is a blueprint of the application you want to work with, of the application you want to run. So what a task definition does is in a task definition, like the one I wrote here, you have your task definition, then you specify the tier, you specify the image, which image you want to use. This image part, you just put the image URI of your container, and then port mapping, you specify port mapping, probably the port your container is running in, or the port you want your container to run on. Yes, it's container port, there's also host port, not added here, and then the protocol. Then you specify also the memory you want for example, if you are using Fargate, you specify the memory you want your Fargate environment to have, the CPU, and then the memory. That's task definition. So task definition, it creates to task definition is used to specify your infrastructure, like what number of CPU your environment should have, storage, the Docker images, the ports, and all other specification. So you can then, when you are done with writing your task definition, so what we are doing today, we will not be using a task definition file because we'll be working majorly on the console. Yes. So this is what a task definition is. So you can use this task after you have written your task definition, you can use it to launch tasks on your cluster. So it's important to note that task definitions are versioned, so you can make changes to them over time without affecting existing workload. For example, what that means is when you have a container, for example, you updated your code dependencies or probably part of your API, you added a feature, and then you build and push your container again. So on your task definition, what you just do is you just reference the new container that you have pushed, the updated image. So your ECRO can have immutability or no immutability. So what that is when there is a container when you build a container afresh, for example, you have a latest, your container is tagged with latest, and then there was a latest container before. So the new container will override the old container, and then the new container will be tagged latest. So on your task definition, you have already said, okay, I need this image and the tag should be latest. So when you make an update, you create a revision of your task definition, and then use that revision to update your task. So, and then when you're updating your task, it depends on the deployment strategy you're using. It can be blue green rolling updates, or blue green, it's you create different environment and then run that stuff and then push traffic to it. Then rolling updates, it updates, and then when that container is ready, it starts removing the old ones and then replacing it with the new ones. So the next slide is talking about task. So, we have talked about task definition. So a task is the instantiation of task definition within a cluster. Like I said, you create when you are done with your task definition, you use your task definition to create a task. So a task is like the running task definition. Yes. So each task that uses Fargate launch type has its own isolation boundaries and um, does not share underlying kernel, CPU resource, memory resource, or elastic network interfaces. They are isolated if you're using a Fargate type. But the difference between this and EC2 is self-explanatory here. So what an EC2, an EC2 is, if you are using an EC2 launch type, they are already existing in the same environment. That means they are sharing the storage of that EC2. They are sharing the memory of that EC2. Yeah, that's just is like is an open difference. Then the Amazon Task Scheduler is responsible for placing tasks within your cluster. So when you launch your task, so there's the scheduler that places that task in your cluster, and then so there are different types of scheduling option available. For example, you can define a service that runs and maintains specified number of tasks simultaneously. Like you can say, okay, your task, you can have like 3 tasks running at the same time of that same service. It's a task scheduler that does that. So you can just keep it at the back of your mind that there is task definition, you have cluster, you have task definition, then you have task. Then after task, we have service. So a service definition in AWS Elastic Container Service is a configuration that allows you to run and maintain specified number of instances of a task definition simultaneously. That's like running several tasks simultaneously. So a service is helps you to run your task. Like if you have like 4 tasks, it's a service that will keep them running. This makes it easy to manage and scale your application without having to worry about individual container instances. When creating a service definition, you need to specify the task definition. Okay, me, I hear you. You need to specify the task definition that the service uses, as well as the number of tasks that it should run. Then, so I just so in conclusion, summary: AWS Elastic Container Service provides scalable and flexible platform for deploying containerized applications by creating clusters, task definition, and service definition. You can easily manage your application deployment and scaling needs. One of the key benefits of ECS that is it integrates with other AWS services such as EC2, ECRO, CloudWatch, what is parameter store, Elastic secrets, AWS secret managers, all the AWS native services. It integrates seamlessly with them. So this allows for seamless integration into existing AWS environments and easy management of resources. So I encourage you to practice on your own after this session or during this session. So I highlighted this part. So if you are practicing, if you are doing this hands-on, do not leave resources running on AWS so that you will not come back tomorrow and you will have some $500 bills to pay. please and please just always ensure that even if it's not this presentation, whenever you run your resource on AWS, try and remove them when you are done. Clean up. All right, so we'll be moving to the demo session shortly. Let me this Cloud9 environment is running. Okay, so the what we are doing is I did not add, we're supposed to start with ECRO, Elastic Container Service, create an ECRO, then register a task definition, create service, then we test, and then we clean up. All right, let's go. So if anybody have question on this, on all we have just said, you can just drop it in the chat. We can just address it why I moved to the environment. So if you have questions, you can drop it on the chat. Let me configure IAM new workspace. Okay. I'm coming, logging in my environment on the background. Yes. So also for ECS, while I'm doing this, let me just send this. For ECS, you have different launch type, right? So that launch type, we have Target, we have EC2. Now, what when you're launching your task automatically?
Sorry, GT. Are you sharing your screen already? Because I
No,
can't see what you're sharing.
I'm I'm configuring. I want to like set up this Git pod. Yeah.
Oh, okay. All right.
Okay. I am. Sorry, I'm just quickly running my IAM so that I don't have to put it in your presence since this is my stream.
Okay, GT. Let me take you out for a bit while you
All right.
get things ready. Um, Welcome everyone. Welcome for those joining. I would like to note that or announce that our DevOps study group is proudly sponsored by the AWS Nigeria user group and also the AWS Nigeria Cloud Security Group. These are our parents, should I say parent companies? So, as much as we're trying to learn, improve our skills, and get hands on knowledge on industry expertise, we also need to acknowledge the people who have given us this opportunity to do what we're doing right now. We believe that after a few months, we should be able to um, gain international attention. And we're not there yet, but I believe we'll get there someday. GT, are you ready? Are you sharing your screen already?
I'm almost ready. Please.
Okay.
Um,
So the plan today is to deploy a DevOps Bank app. So we have a DevOps Bank app that is open sourced. We want people to contribute to this project. We also have other projects coming up. We have a movie search app. We also have a weather app. So the plan is to get different applications and then look for ways to integrate AWS tools in terms of deploying them and monitoring them as a DevOps engineer. So we're starting with the DevOps Bank app. This is the third session. By next week, I believe EKS will be having Elastic Kubernetes service. Taiwo will be the session coordinator. by then we would probably have to move to another application because we've really worked on the DevOps Bank app almost throughout the entire season. We'll still wait for God's time to come up. I'll bring up my other colleague Simi. Simi, how are you doing? Simi, are you there?
Yeah, I'm here. I'm here.
Okay, cool. So Simi is one of the leaders in the T. Simi, do you have any updates to give us or any advice offer as regards the entire curriculum and what we're trying to achieve?
Yeah, I have a few advice. What I would just advise everyone, the same advice I also give myself to, is to keep learning. You revise what you've done before, to perfect it. You keep learning, you keep revising, you keep exploring new fields as tech is ever evolving every day, every minute. New technologies are coming out day in, day out. So you just keep learning. Learning never stops in tech. So you just keep learning. That's just what I would just advise. And for guys who are beginners, I know some of these things might be look a little bit overwhelming. What I would just advise is take a step at a time, a step at a time, a step at a time, and see within they say a few drops of water makes up an ocean, right? So within months, maybe 2 3 months, you can now reflect to say, oh, you see that you've made significant progress if you are consistent with your practicing and also your self development. Yeah, so that's what I will have to add. Have
Okay,
to add.
Simi, you're in the industry. You work on live projects. Do you think what we are doing here has a significant impact for those who want to enter the industry? Do you think what we're doing here can be synonymous to what is being done on the job? Hello, Simi. Are you there?
Yeah, hello. Sorry, can you hear me?
Yes, I can hear you now. Did you get my question?
Oh, yes, I did. So I'll say yes. This is perfectly in line with what you see on your day-to-day job. If you're a DevOps engineer or an SRE or a cloud engineer, this is what you would encounter. Stuff like this you will encounter. Is technology stacks like this that you encounter. And yeah, it is very, very much applicable to what you would encounter in a live or production environment because you have the code, your repository, and then you have your technology to make that code work or to deliver that code to your clients. So to now navigate how to make that your code or your solution to get to your end client. That's all what we are trying to achieve here, and the ways of why you can do that. So yes, this is very, very much in line with real life scenarios.
All right, fantastic. So GT is already sharing his screen. We'll get back to the demo session. Till the end of that, please enjoy the session.
Okay, man. Sorry for the delay. I had some environment issues. So yeah. So our first, I've cloned the applications on my Git pod. This is another repo. I just had to like use these and then clone the application inside because my local environment is quite busy right now. So first of all, the first thing we're going to do is let's create ECR. So be working okay, be working with a new container registry. That's where we start from. So we'll call this bank app. Bank app. Now I'm not disabling tag immutability, scan and push.
Sorry, GT. Are you like what's showing on your screen right now? Because what's showing on my screen is just new workspace for Gitpod. Are you sharing a different screen?
Wow, wow, wow. I'll share my entire screen. Let me. Oh, this is what is showing.
Yeah, yeah, yeah. So,
Is it? Can you see the screen?
not yet.
Let me share. Share
All
screen.
right.
Entire window. Uh, you can see.
Fantastic,
All right.
fantastic.
Oh, sorry about that. So we're starting with ECRO. I want to scan and push so that I'll know if my images are having vulnerabilities. So when you create your ECRO, first you see how to authenticate to the ECRO. First of all, you have to log in, and since I've not built that container, we'll just use the opportunity to build it. My Gitpod already has AWS CLI installed. That's Docker installed already too. So I'm just going to log in. So you see login successful. We have logged in to AWS container registry, this particular one. So the next task is now to build the Docker container. Um, this will take a bit of time because well, Gitpod is quite fast. So why that is going on, we'll move to ECS. ECS. So what we have done now is we have created our registry and we've logged into the registry. So we want to create a cluster so that they take time to like push up, so they will be creating on the hood, working simultaneously. So when you open ECS for the first time, it will show you you will see a get started button, and then when you click on the get started, you see create cluster. So we are calling our cluster DevOps bank app, right? And then here I'm using default VPC. So if you're just creating a AWS account, each region you have a default VPC. So we don't want to go through the hassle of creating VPC, but creating VPC is quite easy. If you are new to AWS, you just on this service tab, you click on it, then search VPC. And then if you know your way around, you just create a new VPC with your subnet specification and your IP siders. So namespace is always auto-populated. Like it takes the name or that you've given to your cluster. And then look at what I was saying with ECS. ECS is majorly you have Fargate by default. So when you want another launch type, you can add EC2. So if you're adding EC2, you now see that you have other tabs to create or to scaling group because you have multiple servers running your task, and then they have to be to scaling group. And then you choose your operating system architecture, instance type, this type, and then the minimum and desired capacity, like you're configuring your auto scaling group on why external instances is, for example, this is ECS anyway. So if you have your servers, your racks, and in your on-prem environment, you can also run ECS there. So, but we are sticking with Fargate because I like serverless. And then, so monitoring, we will not be enabling monitoring, but in monitoring, you just enable container insights. If you enable container insights, it will give your containers like advanced monitoring. You have metrics to read from, CPU usage, all the other metrics. And the what you need to note here is that it is not free. Yes, if you are enabling container insight, you'll be bid for it, and your bid per hour of use, like AWS pay as you use as you go. Yes. Then tags, you can tag it. Do we need to tag it? Okay, let me just tag it. Environments are like environments is demo. Why did I have to auto-populate? All right, so like this, we're done. So I'll create the cluster. So this will take a little bit of time to create. So while this is running, let's go back to our Docker. Yes, you see, we've successfully built and tagged the container. Let me, if we check Docker images, you see that your bank app is here. So if you want to run these to see how it looks like bank app. Docker run. I like to run that in the dash mode. That's the map it to 80 colon 80. So if we check now, the container is running Docker PS. You see that the container is up and then it's running on port 80. So let me open the port here and my Git pod. This is it here. Yeah, so this is the bank app running on GitHub. So the next task is we need to push this image to, if you open this registry repository, you see that there are no images yet. So we've authenticated, we've built, so let's tag this image with the repo tags. So we'll do Docker tag, bank app latest, then your repository URL, and then the tag. Then so we've tagged it. Then next task is to push that container to the registry. The Docker push your registry URL, your app, and the tag. So this will not take too much time. While this is pushing, let's check our ECS. Okay, now we have our bank app cluster created. So this stuff we're doing on the console, it is worthy of note that as a DevOps engineer, you have to know how to automate this. You have to like try as much as possible to avoid using the console, so that if I have a situation where I need to spin this up with a few commands, I can just pick my AWS CLI or Terraform or CloudFormation and just execute the scripts, and then everything will be stood up within minutes. All right. So why this is let me see. Okay, we successfully pushed our bank app to this registry. So you see, there's no image now. If I refresh, because that window, you see that the image has been populated here, is now available on our registry, our repository. So, if you don't have access to ECRO, you can use a Docker Hub. Yes, you can create an account with Docker Hub and then push your images there. It's still the same thing. Okay. Next task is we are done with ECRO. So now let's start running the application. First, we create a task definition. So like we said before, a task definition is a blueprint of our application. So let's start by creating the blueprint of this bank app application. So we're going to call this bank app. Why is this installed in my keyboard? I was working on it locally, so that should be why. Bank DevOps bank app. So the infrastructure is Fargate. So this is where the other launch type now come in. For example, you don't want Fargate for your launch type. You can select Amazon EC2, but we using Fargate. And then VPC. So if you look at, I'll go back to that sample task definition I wrote. You see that the network mode is always AWS VPC. And then memory and task size. So this is where you configure amount of CPU and memory reserve. So if you are in the AWS management console and you don't know what each tab, you can always click info. I always like this tool on AWS. You click info and then it gives you extra information about the particular function you're trying to do. So for task size, you specify the amount of CPU and memory to reserve for the task. CPU is specified, value is specified as a number of vCPUs, while the memory is specified in gig. Here you can see that this CPU is one vCPU, and then memory is 3 gig. So row will be using default execution role for task role and then task execution role. So the difference between task role and task execution role is that also on the info, the task role is an IAM role that is used by containers in the task to make API calls on your behalf. For example, you want to reach services like secret manager like Lambda. This is where you configure it. Why task execution role is the IAM role that grants the Amazon ECS container and Fargate agent permission to make API calls on your behalf. This task execution role is the role that we tell CloudWatch that they want to push logs to that play to CloudWatch. Yes. So now this is where we start turning out our application. So the name is bank app, and then in this image URI, if you are using a Docker image, for example, it was an engineer's container I was using just now, just type nginx colon probably latest, right? And if you run this task definition, you are saying that you want the application name to be bank app, and then you use the nginx image. And then this essential container is actually saying if it's like essential as it is. Why they ask this, I think, is because you can have multiple containers in your task definition. For example, I want this. For example, our bank app probably have a MongoDB container as a database. We can actually add that container to our file, to our task definition, and it runs it here. So what we are doing here, we're not using Nginx, we're actually using time is running. We're actually using image URI that we built and pushed to ECR. So you just specify your image URI. So if you are using a Docker Hub or other registry, for example, you can specify your private registry authentication. So what you do is just save the probably your Docker registry password and username in secret manager, and then you put the ARN of the secret manager so that it references the secret it's using to pull that image. But ECS has ingrained integration with ECR, so we'll not be needing this. So port mapping, our container runs on this port. Let me confirm. So if I cut Docker file, let's see. All right. Okay, yeah, expose 80. So what is for resource allocation? It's we're using one CPU. Then that's because of the one vCPU. Then for memory hard limit, we have 3 gig specified here. Soft limit is like the lowest. So environment variables, if we had environment variable, probably DB name, probably some keys, we can either put it here or we can save it. It is always better to save your environment variables in secret manager or parameter store. Yes, but if you have a specification that enables you to save it here, probably environment variables like specifying if this is dev or prod, that kind of stuff, you can add it here. But for sensitive credentials, you are it's better saving it in secret manager, AWS secret manager. Yes. So are we using log collection? Not yet. So I just disable this. And head check is optional. So for example, head check is very, 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 very important. If your application is running on a path, your head check is in your application is different from the majorly. Most head check are in the slash path. Yeah. So let me see. Some applications you just see their head check here. So when you visit the URL of the application, for example, is console.aws.com/. Yeah, it will return, give a HTTP response of 200. That means the application is okay. So your container also have head check. So you can specify the URL of the head check. You can just put it here. And then, so when it runs, you can call, for example, look at this, call -f http localhost /. You see this slash is always the root path. So in case your application head check is running on a path different from this path, it is always advisable to put the red path in the head check tab. So container timeouts, we're not doing that. Docker configuration, we already have a Docker image. We're not having special configuration, but for the benefit of others, let's just check what AWS documentation says. See, Docker configuration provides a way to override some of the values in Docker. For example, in your task definition, you specify some values. So here, you can actually probably say you don't want to use, for example, you have a task definition for one, and then you want to use that as definition for production, staging, and development environment. So you can use this Docker configuration to say, okay, this task should run development workload, and then the other task should run production workload. Yeah. So without further ado, I will just create. Will not need. So let me tag this again to environments demo. And then we'll create this task definition. It doesn't take time. Yeah, it doesn't take time. So next thing is to our task. So to create your task, you go through your cluster, backup, and then here you create task. So we launch a new task. Our task is because our cluster, for example, if you had multiple clusters here, you will see that it dropped down to select the cluster you want to create tasks from in will be highlighted, will be open. So this one is grayed out because we only have one cluster. So we're using capacity provider, and then we're using Fargate, right? So here we now specify now we are deploying task. We're not deploying service. So since we are deploying task, you specify your task definition. You see, our task definition is the bank app task definition we've created before, and then it only has one revision. You see, there are only one revision populated. For example, we'll go to change that Docker file, probably change from latest to V1 or V2 or any other tag. You now create a new revision from this one we have created before. And then when you come here, you can change. This is how you update. You can change the revision your task should run here. You just, if you have two revisions, you can just select either latest or the old one. Yes, for example, you want to roll back, so you can use this scenario to roll back. Then for network, we've already chosen our default VPC. And then in that default VPC, there is a default security group. And this default security group always allows all traffic. Yes, for inbound rule. We'll confirm that. And then if you want to run your task, like if you want your task to be publicly accessible, you enable public IP. But if you want it to be privately available to your probably is to your servers for front end, you don't want the backend APIs to be accessible on the internet, you turn off your public IP. So I think we are done. So let's create our task. So you see that it's provisioning the task. So give this a bit of time. So our task is running. Let me remove this. Yes. So this task is running. So if you want to access this task, you click on the public IP address that is popping up right here. And when it loads, we should see our beautiful app. We should see our beautiful app. It's probably slow because the task might still be instantiating. Head check is unknown. Okay, details log configuration. So because we did not enable this, we will not, let me put this up. Because we did not enable log configuration, we will not see any log. And network binding. So network binding, this is where you see the external link, the IP address of, and then the ports your application is running on. Then Docker label. If you have label if you added label to your containers when you were creating the task, you see the label here. The environment variable too. You see your environment variable if you had specified the environment variable. So we cannot access, let me see. HTTP. So the only corporate.
Sorry, GT, are you there?
Yeah.
So security groups.
Yes, that's where I'm going right now.
So that security groups needs to allow that port
Port
8080.
80. Yeah. Yes, I just this implicit declaration. I think for all traffic, I don't think it works. So this is default security group, and oh, okay. So see, this is so the only reason why this did not work was because if you see the security group is allowing all traffic, but it is allowing all traffic from this VPC. If this security group, if we investigate, you see that this security group is a security group from that allows traffic from this VPC. So we just add another security group to give me port 80 and then 0.0.0. In production, you are not it is very, 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 in fact, you should not do this. It's by law, you should not do this to your endpoints in production. for your APIs, probably even client-facing applications. I don't think you should expose them to the world. What you can do is you create a load balancer, um, and then use the security group of the load balancer so that all calls coming to your application, we go through that load balancer, and then we come to your infrastructure or environment. So yes, I've edited the security group, and voila, our app is coming up. Yeah, it should come up. Nothing should stop it. Yeah, so this is our bank app running on ECS. So, for example, we want to update this ECS task definition, and then use the, for example, we updated our application. Okay, sorry, how much more time do I have? Okay, for example, we want to version our task. You see, you come to this the same task definition you created before. You click on it and then create revision. No, let me just click on this stuff. Yes, you select your bank app and then create new revision. Create new revision, and then what did I change? I just create it like that without changing anything. You see that on this place in this revision, we now have two revisions. So, for example, you updated your application and then you want to use the new update to deploy. You want to deploy the new update. So what you do is you now come to your task and configuration. I'm coming. Bank app. I think I have lost infrastructure task.
GT, I think you have to go back to the cluster. Go back
Okay.
to the cluster. Yeah. Then from there, you can now add a new task.
Yes. Yes. So yes. So when we do that, we select the bank app. You see that you now have two revision here. You have latest. It is second revision that becomes latest, and then the old one will not have the latest tag. So that's how you do updates for your task definition. For example, this task now we want to enable auto scaling. If you select use auto scaling, you just select your minimum, your maximum. Then if you have your policy name, you can select from the one AWS the metrics you want. You can select CPU utilization, average memory utilization, and then select the target value. For example, when your average memory goes to 70% or above, you should scale out, and then same thing for scaling down. Yes. So for service, now let's create a service. Let me check the chart. Service, so we are using same capacity. Then we're specifying the bank app. We're using latest service name, bank app 2. And desired task. I want 3 tasks in my service. Networking, same thing, will not change it using default. Then load balancing option, we don't want to enable load balancer. Then service auto scaling too, we don't want that, so we just create service. When you come back to cluster, you see that you have service did not create. Why? Okay. So what AWS does is when you create your service, it's you see that it instantiates a cloud formation that creates all the background connections and orchestrate this the service. Service is probably, you see that I selected more than one task. Probably I want to have three tasks in my service running. So under the back end, yeah.
Sorry, GT, we have to round up because it's past 9 o'clock. So
Oh, oh,
let's
oh.
round up.
All right. That's
Let's
it.
round up,
So when the
please.
service
Thank you so
spins
much.
up, the services will also run like the task. You have an IP address you can use to access your service. So what AWS does is they'll balance the traffic coming from that IP address or the endpoint you're using to that particular service. So yeah, thank you. We have come to the end of this hands-on. I hope we learned one or two. Thank you very much. Yeah, if you have questions, you can drop it on the chats. All right, Kemi, you have the floor.
Yeah, all right, guys. Thank you so much, GT, for doing justice to this topic. We have one question in the chat. It's from Samuel Ekele. I hope I pronounced that right. Samuel is saying, what are the advantages of AWS ECS over other container
Okay,
services?
the cheapest answer is it is if you say other container services, probably you might mean Kubernetes or probably Docker Swarm or probably other cloud container service. For I'm comparing it now with EKS. For Kubernetes, ECS is cheaper, yeah, to use for because you're not managing a control plane and your you can have containers running as serverless containers, so you don't have to manage servers. So when traffic does not come to your application, you are not billed. Yeah, it's cost effective than EKS because EKS, whether you use EKS or not, once you spin EKS up in per month, you have to pay about $70 for the control plane maintenance, and it's handled by AWS. Thank you. Any other question?
Any other questions? So the key takeaway from what GT said is the fact that EKS has Fargate, which is very cost effective and it is serverless. You know, the fact that you don't get to pay for compute service when you're not using them. So only when the endpoint is reached is when you pay for that service. So that serverless is a big deal. So there's another question from Adeyemi Lawal. By creating the service, you are creating an endpoint that can be used to connect to the application. So that's not a question, but a contribution. Thank you so much, Adeyemi Lawal. GT, do you have something to say about that?
Yes, no. By creating a service, are you creating an endpoint? Okay, is a question that can be
Oh, it's a
used.
question. Are
Yeah,
you okay? Yeah. Are you
yes, yes,
creating an endpoint
yes.
that
So
can be
when you
used to
create a
connect to the
service,
application?
when you create a service, like there was we had an IP for task. You have an endpoint to reach our application. So service kind of load balance your request to the number of tasks running in your cluster. Yes, when you use service definition. Thank you.
I hope that answers your question. Adeyemi Lawal. Do we have any other questions? Obasoro Ola Kunle is saying thank you for this. Thank you. Any other questions? All right. So With that being said, no questions for today. Thank you so much, GT. Thank you, Simi, on the background doing things. I see you, Adeyemi Lawal. I see you, Obasoro Olakunle, Emmanuel Ekele, Emeka Ohiri, and every other person who has participated in this session. Thank you so much for being a part of our third session in the advanced curriculum. We'll have to call it a day from here. If you have any questions, you can post the questions on the WhatsApp group. I believe we're all on that group, and we would get across to you. Thank you so much for attending, and good evening, and enjoy the rest of your day. Bye bye.